Oh, fellow hams and YouTubers. Well, I took on a minor repair, and I say minor, but boy, this radio is in need of major work. What we have here is an older ICOM IC 751A, and the radio has seen better days. It's pretty scratched up and beat up. There's a few of the screws that have been broken off. The stud from the screw is still in the hole. Missing knob here. Scratches, a little bit of rust here, some signs of rust back on the heatsink, like it was in a humid environment for a while. But it's mostly functional. The owner, current owner, this thing's been handed down through several owners, said it works pretty well except for one issue. And what he's seeing is distortion on the upper bands. And I'm going to illustrate that for you. That's Radio Havana right there. I'm going to switch to a sideband mode. And we'll go, oops, a little off frequency there. All right. I'm going to tune my signal generator over to generate a carrier. And let's see. It's warming up, that's why it's drifting, the signal generator. But you can hear that tone. That tone is nice and pure, which is what we should hear from a carrier. We should just hear a nice pure tone. Now let's go up, let's say to 11 megahertz. And I'll bring the generator up there. That should be a tone. So that should be a tone, but it's a scrambled mess. And I know exactly what's going on. In the PLL circuit, the voltage controlled oscillators are out of adjustment. And what's happening is, well, it's a whole nother video to talk about how PLL circuits work. Phase locked loop circuits, but they're high stability frequency sources that replaced just regular old VFOs years ago. The advantage is that they tend to lock into a frequency and stay there, so they're very stable with very little drift. But if those voltage controlled oscillators are out of adjustment, what will happen is that PLL circuit will be unable to lock in to frequency, and it will continue to try, and it'll hunt. It'll sort of bounce up and down in frequency like that. So that's what we're hearing, is the VFO frequency is actually bouncing up and down quite a bit, really rapidly like that. And it's making that tone sort of scramble. You can hear it. It'd be like somebody sitting there just vibrating that tuning knob back and forth really fast. So that's his main reported problem with this radio, and it's only happening on the upper bands, which again points me to the VCOs, because there are several. There's, I think, 3 or 4 VCOs, and they handle frequency ranges, you know, the low end of the HF spectrum, this range, and that range, and all the way up. So we're reaching a point where we're switching into one of the next, like the bottom VCO is working, and the next one's way out of whack, and then as you move up, they're all out of whack. So all right, we are set up to do the PLL adjustments. I have the instruction sheet printed out here. ICOM service manual is mostly accurate. There's a couple of errors in it. One notable one is at this point here, you actually have to connect to a different test point for these frequency ranges. Mr. Carlson's lab had a nice little look at this manual and a couple of errors they had in it. Another error they had was for setting the reference frequency. They had you connect to R1 on the R2 side. Well, that's actually the 5-volt power rail for the oscillator. When you look at the schematic, I'll pull up the schematic here and I'll point it out. The oscillator is, here we go. The oscillator is here, and that R2 and R1 junction is right here, which is the 5-volt power rail. You've got your DC supply coming in here through a 220 ohm resistor. There's a Zinger diode which creates 5 volts to create a stable voltage source for this oscillator. And they wanted you to connect here, which is the 5-volt power rail. That makes no sense. You're not going to read any frequency there. You'd want to get frequency at the output of the oscillator. And actually the place that I measured it was on the other side of this buffer at the chip where it's injected into this IC. A buffer amplifier takes the, well, it isolates the oscillator from load changes. If you were to put a probe here on the oscillator to measure its output, that probe's impedance would change the load on the circuit and thereby shift the oscillator slightly. So a buffer is a unity gain amplifier that does nothing more than provide a constant load to the oscillator so load changes on the output don't affect its frequency. So I'll measure over here on pin 1 of this IC, which I already did, and the reference oscillator is dead on frequency. So ICOM manuals sometimes have errors in them, which is a little annoying, at least these older manuals do. But as far as the PLL adjustments go, we're ready to start adjusting. Now I've got my oscilloscope probe in here, and they give you test points in the diagram, or the instructions. They tell you what value you're targeting with your adjustment. They tell you the location for your test point. And then they tell you what control to adjust over here. And then that is accompanied in the manual by a nice photograph of the board, which has all the test points listed over here and pointed out. So it's very easy to find the test points. One thing that I did have some trouble with, these 2 inductors you had to adjust, they were coated in wax. So I had to very carefully with a pin dig the wax out of the slug so I could make those adjustments. And this is the lock voltage for the low frequency range PLL, which I'm on right now, and the output level. And I've already adjusted the output level. You just put a scope on it. You put a scope on the test point over here, this coil, and you adjust for maximum output. So that's pretty straightforward. Doing this adjustment, it's a DC voltage that you're targeting. So going back to the alignment procedure, I have the scope. My oscilloscope is hooked up to the resistor. Lock voltage PLL, connect an oscilloscope to R202, which I'm connected. They've got a nice arrow on the board that points to which side of the resistor to connect to. And your value is supposed to be 3 volts. So looking at the oscilloscope, I'm going to try to do this. I'm measuring a DC voltage here. That's weird. On my preview, it's... When I tilt my camera's screen for preview so I can see it from this side, everything's reversed. That's funny. But as you can see, the mean voltage right now is 3.08 volts. They want us to target 3 volts exactly, so I'm going to tweak that a little bit. I'll leave this camera on the scope, and I'll just tweak that inductor. Oh, wrong way. Trying to be too precise, I think. There we go. 3 volts. Haha. So that one was actually really close, and that makes sense because that's the lower frequencies from 8 megahertz and down. And that's where we were receiving good audio. Okay, adjust the frequency display to 7.99999 megahertz. I heard the relays click as we switched circuitry in there for the lower section of the radio. Same test point, and I want to target somewhere between 1.5 and 2 volts to verify. And we are at 1.52 volts, so yeah, we're within the range. It doesn't say to make any adjustments, it just says to verify it. And it is within the prescribed range. So now we go to Different test point. Connect the oscilloscope to R46. R46 is up here. R43, R44, R46 right there. Let me get my scope probe out of here. R46. And we're seeing 6.28 volts presently. And they want us to adjust a trimmer cap down in here. Sorry about bumping the camera there. And we're going to target 6.5 volts. We're adjusting C78. C78 is this bottom one. And we're targeting what? 6.5 volts. C78. Okay. This isn't the right tool. Hold on. Oh, here we go. And get this on there. Okay, and we're after 6.5 volts. So let me, my scope adjusted there. .5 volts. Okay, now we move the frequency to 14.99999. .9999999, and again we're targeting 6.5 volts, and we're adjusting C88, which is the next one up. Yeah, it's a little off, 6.2. And right, almost 6.5 volts. Okay. Frequency displayed at 21.99999. And 21.9999999. And again, we're targeting 6.5 volts, and we're adjusting C97, which is this one. We're at 5.5 volts, way off. I think that cap is dirty. I had to swing it back and forth a few times to get it to behave. Okay, 6.3, 6.5. All right, 29.99999 is our next adjustment point. .29, and we're adjusting C97. No, we're adjusting C107. Again, targeting 6.5 volts. It's currently at 6.2, and that's this cap up here. Mm, 6.4, 6.6, very touchy. 6.5. Okay. Now we're going to move our probe back to R202, which was over here. And we're going to put the frequency at 8 megahertz. Oop. .8 megahertz. And we're going to adjust L201 for our target of 3 volts. Well, we're at 3 volts. I don't have to adjust that. And wow, that's interesting. They have 3 frequencies, same voltage and the same adjustment point. 15 volts, or 15 megahertz, we should still see 3 volts. 15 megahertz, yeah, 3 volts. 22 megahertz, 3 volts, and then we go back down to 7.99999. Connect the oscilloscope to the cathode of D8. Where is D8? R2, J2, L2, J1, R1. D8 is over here. That's D7. That's D8. I hope the cathode end is the end that's sticking up. 2.48 volts, and they want it to be 2.5 volts. And we're going to adjust R43, which is right next to it, for 2.5 volts, and it is showing 2.48. That's pretty close. .5. Okay, in theory, the PLL circuit should now be adjusted. So what I want to do now is I want to inject a signal back into it and see if it sounds clean up up in those higher bands. So I'll bring my RF generator probe over here close to the antenna input. And volume up. We'll go up to 11 megahertz. Frequency generator on. And we're still distorted. So it's not a problem with the PLL. Interesting. Okay, well, I've pulled the board and been taking my magnifying lens and looking at all the solder points on the bottom, especially focusing over in this area. The heat sink for the voltage regulator is right here. And while it was operating, I touched it, and even with the heatsink, it gets pretty hot. It was uncomfortable to keep my fingertip on for too long, but that's within the thermal specs of that regulator. That's not uncommon to see them get pretty warm. But because this is the bottom of the radio, and that heatsink is essentially gravity-wise below the board, that heat rises, so this part of the board gets warm. And sure enough, over in this corner I've found several iffy looking solder points. There's one really bad one there. Several of these over here have small dark cracks around the pin where the surface of the solder is cracked. So those connections could be iffy. I'm going to remake all of those. Nothing else seems bad. I've looked over the entire board with the lens. I don't see any other bad areas. So it's all right in this corner. So we'll remake all those. The other thing I'm doing, they've got these springy ground fingers here that press against the metal chassis to improve the grounding on this shield. That's to keep this part of the board quiet. This is where the VCOs are, and they definitely need that to be RF quiet. So I've bent these about another millimeter up to increase the pressure, and there's a couple of spots down in the chassis where I can see some dark pattern from where this was making contact. And for a pattern to occur there has to be motion. There has to be just a small amount of heating and cooling expansion making this finger rub on the chassis, and that makes it dark down here because that's dust, that's metal dust. So I'll clean that up too to improve those grounds, and then we'll put the board back in and see if that solves the problem. Soldering iron is heated up. Time to remake some solder connections. Reheating those causes the solder to reflow and onto the pin and the pad and makes it a good solid connection again. Alrighty, those, yep, that's all of them. The rest of them look fine, so time to put the board back in and see how it does. Well, I got the trimmers in from ICOM for this radio. There's the old trimmers there, the old plastic trimmers. I didn't film the replacement because I wasn't very hopeful that it was going to solve any problems. When I did the adjustments before, the voltage was stable. I didn't see any noise on the voltage, so I didn't think that the trimmers were actually going to be the problem. I thought it was going to be something else. But got the new trimmers in, just went through and did the same adjustments again, and we're up at one of the higher frequencies here, almost 23 megahertz. And a nice tone. Nice and well, stable as can be with my my lousy frequency generator. But you know, before we had just nothing but ratty noise there. We couldn't get a tone at all. So, darn, the trimmers actually solved the problem. That's pretty amazing. I wouldn't have thought it would have worked with the voltage being stable with the old trimmers. I didn't think that was going to be the problem, but it definitely was. So I'm going to button the radio back up, make an on-air contact or two to make sure that it sounds fine, and we'll get it back to the owner. So this repair is done. Oh, let me point the camera down in here. Getting this can off, I took the board out, and underneath there's shields on the bottom and this can, which is soldered at the corners, and that was a pain. Solder sucker got these corners hot enough where I could suck the solder out. But then you just kind of had to work your way around, pulling up on the lid and working it loose a little bit at a time till it came off. And so that was a real pain. The caps themselves were surrounded by wax inside of there, and the shield on the bottom of the board had, 12 tabs around the bottom of it that were soldered to the board. And I sucked most of the solder away with the solder sucker, but then I had to work my way around that shield too, just pulling up on it and lifting it a little bit with each tab as I went around it until it finally came loose. It was a real pain. Replacing the trimmers was nothing. They desoldered and the new ones went right in, but boy, getting this shield off is a real joke. You just have to take your time, be real patient with it if you have to do this yourself. And try not to spatter any solder on the board or get it too hot around there. This wire was actually routed right next to, this red wire was actually routed right next to the can. And I moved it out away from the can before I started heating it so that I wouldn't risk burning through the insulation on the wire and shorting it to the can. So watch for that. Other than that, it was pretty straightforward. And we got a nice tone now. That tiny little bit of variance is my crappy Heathkit signal generator, which is on its last legs. It's doing that. This actually sounds right. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.